Okay, this is multiplication properties of exponents. You're going to know the rules of multiplying and simplifying exponential expressions. Let's observe what happens when we do some of these problems right here. Okay, so you have a few of these, I think, in your notes to look at. 3 to the 4th times 3 to the 5th. Let's write out the math of that. 3 to the 4th is 3 times 3 times 3 times 3, right? Okay, and 3 to the 5th would be, let's just continue that. I need 5 more 3s. 3 times 3 times 3, 1, 2, 3, 4, times 3 times 3. So here's my first 4, okay? And here's my next set of 5. So basically, instead of saying 3 to the 4th times 3 to the 5th, I really have 3 to the 9th. Okay? Let's just leave that at that for a minute. Let's try 2 to the 3rd times 2 squared. So we have 2 times 2 times 2. Okay, there's my first 3. I need 2 more. Times 2 times 2. So essentially, that is 2 to the 5th, right? Okay. Now, I have the quantity 4 to the 3rd squared. So that means I'm going to take 4 to the 3rd times 4 to the 3rd, right? So that's 4 times 4 times 4, okay? And then I can do that again because it's squaring it, so that means twice. Times 4 times 4 times 4. So essentially then, the quantity 4 to the 3rd squared becomes 4 to the 6th. The quantity 6 squared to the 4th power. That means I'm going to square 6 4 times. So 6 times 6, do that again, 2 times, 3 times, 4 times, right? So that's 1, 2, 3, 4, 5, 6, 7, 8. So 6, the quantity 6 squared to the 4th really becomes 6 to the 8th. Do you notice how in these two we went from what was in white to what I simplified to here? And in here, 2 cubed times 2 squared to how I got 2 to the 5th. What did I end up doing with these exponents? Thank you, Dakota. I just added them, didn't I? When the base number is the same, these were both 3s, can I just add the exponents? 4 plus 5 is 9. Here's the math to prove it. When my base number 2 was the same, I just added the exponents. 3 plus 2 is 5, and here's my math to prove it. Okay? That becomes the product of powers property. In your base number, and here it's A, when it's the same, you can take your exponents and add them together. Product of powers property. I think in your textbook on page 441 is called multiplying powers with the same base. It's the same property. Okay, the name doesn't matter, just the fact that you realize because it has become a rule. Okay? Let's go back and look at this one. These last two. How did I get the quantity 4 cubed squared? What happened to the 2 exponents for me to get 6? 3 times 2 is 6. There's the math to prove it. Is 2 times 4 8? Yes. And there's the math to prove it. This becomes power of a power property. So when you have a number, a to some power times n, you're going to multiply those together. And in another form, if you were to have 2 numbers, then with the power out here, this would in fact need like the distributive property. The power would go to both numbers. Okay? Let's just put this into practice. We're just going to do several practice problems here. Here we go. Write down A. A is 5 to the 8th times 5 cubed. Okay, do I have the same base number? Yes, Kylie, I do. So it becomes 5, and I don't like blue on that. Guess we're going to go with red. It becomes 5, 8. I add my exponents, 5 to the 11th power. Okay, if you want to write what that equals in your calculator, that's fine. Let's go to B. 7 to the 4th squared. That means 7 to the 4th times 7 to the 4th. 4, since these exponents, I'm going to multiply, so it becomes 7 to the, yes, Eric, to the 8th. Okay, moving on to C. This was our third property. So I can either multiply these together and it becomes 21 squared, or I can say 3 squared times 7 squared. If we actually do the math of that, it would be the same number. 21 squared is 441. We know 3 squared is 9, and we know 7 squared is 49. So 9 times 49, again, is 441. Okay, I would take either of those responses. Moving on to D, 5a, negative third exponent. What's going to happen? This applies to both things inside. That it's negative. That means it has to go where? In the denominator. So I put a 1 on top, and it becomes 5 cubed times a cubed. Can I cube any of those? Can I get an answer? Yes, Justin, I can. Which one? 5 cubed. So it becomes 1 over, what is 5 cubed? We should know some of these cubes. Probably 1 to 5 would be good. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. A cubed. Okay, that's D. Questions so far? See me. E. 3y squared times 2y to the third. What can I do here? I can multiply my coefficients, right? 3 times 2, Nathan, yep, is 6. But then my bases here have the same exponent, or same base, so what can I do with those exponents? Add it together. So 6y to the 5th. Because essentially this is 3y times 2y, or sorry, I messed up on that one. My bad. Start over. I didn't pay attention to the parentheses. This one is 3y. 2, I didn't distribute. Big distribute mistake number 1. 2 to the third power is 8. Y. 3 times 8 is 24. Y to the 5th is actually the correct answer. Okay? Let's do the same thing over here. This is going to be the opposite of the quantity 3x squared, squaring both the 3 and the x. Okay? 3 squared is 9. X, that's negative 9. Times 7 to the 4, x to the 4th squared. So I square 7 and I square the 4. So it becomes times 7 and then 4 x's and then 4 more. Okay, so there's it actually written out. If you want to simplify that, you get negative 63 x squared, x to the 8th. This becomes the 8th, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because 8 plus 2 is 10. Whoops, x to the 10th. My bad there. G and H. Here I have negative RS times RS cubed squared. Okay, so that means I'm squaring both things in here. So it becomes negative, negative RS times R times R times 3 S's, and then 3 more. Okay? So it becomes negative R times R, negative R cubed. And actually, then you got to multiply it by S all the way through, but we're just going to do like terms here, times. And S, how many S's? 1, 2, 3, 4, 5, 6, 7. S, 7. So look at H, negative x to the fourth, that becomes x to the fourth. Negative x to the third becomes negative x to the third. And negative x squared becomes x squared. How come these didn't stay negative? I just said that. I didn't show you the math. When we write out the math, remember back to 7th grade when we learned multiplying integers, when we have a even exponent, that means every negative is going to have a match. Here's the math for that. Positive. Positive. So it becomes a positive number. We have an even numbered exponent. So we have x to the fourth times negative x to the third times x squared. So that's going to become negative x. 4 plus 3 is 7 plus 2 is 9. You want to put that in parentheses because it's not the opposite of x to the 9. It's negative x to the 9. Moving on to some of our final ones here. Going a little quicker. 3a cubed becomes 3 cubed times a cubed times 2a squared, 2 squared times a squared. 3 cubed is 27a cubed times 4a squared becomes whatever 27 times 4 is, a, not to the fourth, to the fifth. All right. How about here? This becomes w to the 6th, x to the 8th, y to the 2nd. I'm not showing you the math anymore, just using those properties. And this side becomes w to the 4th, x to the 8th, y to the 12th. Hopefully you know how I got those. And I'm still multiplying all of this together, so when I have the same base, w, x, and y, how many w's am I going to have? How many, Abby? 10. How'd you get 10? 6 plus 4. How many x's? 16. How do we get 16? 8 plus 8. How many y's? 14. How do we get 14? 12 plus 2. Okay. Go ahead and try K. It's going to be, go ahead and give you just a second. First did it, then I have s to the 8th times p to the 12th times s times t. So it becomes s to the 9th, t to the 13th. Lastly, mn to the negative 2nd squared becomes m squared n to the negative 4th. I want to get rid of the negative exponents. M squared over n to the 4th. Make sure you get your guided practice done and come with questions if you have any tomorrow.